Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Roxanna. For math homework help, call in Bakersfield 66-4357. Everywhere else, 1-866-66-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
All right, nicely done, Roxanna. That wasn't too bad, was it? Where do you go to school?
I go to school at Berkshire.
And how is Berkshire?
It's really nice.
What grade are you in?
I'm in 5th grade.
Have you been at Berkshire for all of your schooling, or are you pretty new to the school?
I've been in Berkshire for all my schooling.
For all your schooling. So next year is 6th grade.
Yeah.
Is there anything you're looking forward to in 6th grade?
Well, not really.
Okay.
But I'm looking forward. I love my teacher, but I like to get new teachers, so I like
All right, well, it's good that you like your teacher now, but it's always nice to get another teacher too, right? So is there anything that you have already, because I know that you've got an older brother, is there anything that you're looking forward to in junior high school? Because next year will be your last year at Berkshire.
I look forward to like going to different classes.
So you think you'd like that?
Yeah.
All right. What is your favorite class right now?
My favorite
Even though you don't go to a different
Yeah.
room, I think, but what is your favorite topic?
reading.
So reading.
Yeah.
All right. And I know you and Sophia were talking about one of your favorite books is what you're reading now, right? And you have also said that you are in music, correct? Mm-hmm. And is it band or orchestra?
Band.
And what instrument is it?
Clarinet.
And you're a master of the clarinet now?
Yeah.
All right, good. Well, that's the way to say it. Yeah, you're a master of the clarinet, right? You get that thing down. All right, so I'm glad that everything is going well for you in 5th grade. How is math going for you in 5th grade?
Pretty good.
What kinds of things are you working on in class?
Long division.
Long division.
Yes.
And is that pretty easy for you? You feel comfortable doing that?
Yes.
Is there anything that you've done that you think you need a little extra help with at all?
Not really.
Okay, so as you've been doing everything, you're kind of understanding it and everything seems to be going along pretty well? Mm-hmm. All right. Have you done anything with fractions yet this year?
Not that I remember.
You haven't done anything with fractions yet? Like 1/2 or 3/4? Anything like that?
I don't think so.
Okay, it could be a big day for you now, sister, all right? So maybe we'll do some fractions later on, okay? But before we do any of that, we're going to remind everybody that the phone number is 636-4357, and if you phone in today and we do one of your math problems, you will automatically win yourself a pass to Holiday Lights at COM, and today is the final day for that opportunity. Today, the 11th, I believe it is, of December, is the final day because this is the last live broadcast for Do the Math until we come back in 2025. So you're on the final show for this semester. Are you ready to help me out with that social media problem of the day?
Sure.
All right, let's take a look at it together. It's going to be right up here on the screen. So it says, which quadrant would this point belong in? So it has 3, -4. And it says quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Do you have any idea what any of this stuff means?
No.
All right, because if you haven't done quadrants yet or coordinate planes, that's going to look a little weird to you. All right, so how about we do this? Let's come on over to the board. All right, so head right on over there, okay? So I'm just going to draw something up here really quick, all right? And let's say I have 1, 2, 3, 4, okay? So this is the x-axis going across, all right? The y-axis is going up and down, all right? That's the vertical one. So if this is 0, 0, right? And I'm going 1, 2, 3, 4, like a number line. What number would be here? If this is 0 and I'm going back, what would this be?
Negative.
Yeah, -1, right?
Yeah.
And then what?
-2.
Good. And then?
-3.
And finally, what else?
-4.
Good. All right. So we know that the positive numbers are going to go in that direction. Negative is going to go this way. All right. That's on the horizontal plane, the x-axis.
Yeah.
The y-axis is going up and down and vertical. If I go up, I'm going to go positive. So what number would be first?
1,
1.
2, 3, and 4.
Okay. Now I'm going to go down. What do you think is going to go first?
-1,
All right.
-2, -3, and -4.
And we'll just stop there. I mean, that way we've got 4s all the way around, okay? So if I had a point right here, I want to say the x number first. So I'm looking along this line, this axis. So what number is this point lined up with?
1,
1. And I'm going to put a comma because it's x and then y. So if this is the y-axis, what number is this lined up with?
1,
So I'm going up. How far up did I go?
1.
1.
Yeah.
So that point is at 1, 1. Does that make sense?
Yeah.
Kind of?
Yeah, kind of.
All right, let's try another one. Let's put 1 right here. All right? So think about it. We're going to take the x-axis first. Okay? So what number is that point lined up with?
2.
Well, I'm going to go across first.
Oh, okay. So,
If I look at these numbers down here, which one is it lined up with?
3.
Okay, so write down a 3 first, then put your comma. Now the x is done with 3. So now we're going to go on the y-axis. So which number is it lined up with on here?
2.
So put a 2, and then close your parentheses. So that point is 3, 2.
It's starting to make sense.
Starting to make sense? Right, it's not going to make sense the first time you do it, right? But these have names, okay? So this is quadrant 1, okay, because both numbers are positive. We're going to go in a counterclockwise direction. This is quadrant 2, because the x number is negative and the y number is positive, okay? What quadrant do you think this is? There's 1, there's 2,
3.
3. And we're writing these in Roman numerals, okay? Now, that means any numbers that are over here. The x number, is it going to be positive or negative?
The x number will probably be negative.
Negative. And the y-axis, is it negative or positive?
Negative.
Negative. So in quadrant 3, they're negative and negative. Now, what do you think this quadrant is?
Positive. Wait,
So we're going to go, first of all, let's name it. So it's 1, 2, 3,
4.
4. So this is quadrant 4. Now we need to know, are they negative or positive? So the x numbers, are they positive or negative over here?
Positive.
Positive. So put a positive symbol there.
Is it like this?
And the y-axis, the numbers down here, are these positive or negative?
Negative.
So put a negative symbol in there. Now let's take a look at the problem they've got for us again up on the board. So it says, which quadrant would 3, -4? So let's put this down here. We'll put 3, -4. So the first number is positive. So which one of these has a positive number?
This one?
This one does, right? Okay. And then -4. So if the first one is positive, the second number has to be negative.
Yeah.
So we need a positive and a negative. So where is it positive and negative?
A positive and negative is right there, like the 3. Like, wait, I don't know.
So this is negative, positive.
Yes.
This is negative, negative. This is positive, negative. This one we know is positive, positive.
Yeah.
So we're looking for a positive, negative.
That would be this one.
That would be down there, right? Because if we did 3, -4, we go over 3 and down 4, and it would be about there. Now, this is a lot to take in for the first time you've ever seen this, right? But you kind of get it a little bit?
Yeah.
All right, so first, let's take a look right now and see if 3, -4 was in quadrant 4. So A, B, C, or D?
D.
All right, let's take a look and see if it is correct. There you go, D is correct. First problem done, sister. That wasn't too bad, was it?
Yeah.
All right, you know what? Time now for today's Math in the News.
Awesome. Thanks, Mike. So we're out here with the Calm staff. We have Chris and Meg. Thank you guys so much for being out here. I see we have a tortoise. He's been chowing down the entire time as we wait to go live. First off, tell us what you do out at Calm, and then let us know about your friend Henri that's here with us today.
So out at Calm, I am what's called an animal keeper, which pretty much means I do the day-to-day care of the animals out there. Everything from feeding them to cleaning them, medication, to also, like, to a small degree, constructing their habitats and doing their enrichment. And then Henri here is actually one of the animals I do take care of. Out there, I'm on the string called the farm, so we have the big farm area, and then Henri is also with us. He's up in the big front round by our gift store. What's cool about Henri is he's a African spurred tortoise, also known as a sulcata tortoise, and he's unique to Calm because he's not actually a native California animal. So they're actually common in the pet trade, and that is potentially where Henri came from in the beginning, because he was just a found roaming animal, and that's where he was before he came to Calm. They got him as just a tiny little thing, maybe about the size of a little silver coin or something.
Hold on, I guess I gotta ask, how old is Henri?
So Henri is an estimated birth because we didn't hatch him, but because of the size he was found at, we assume he was born in the beginning of 2019.
So this guy's roughly 4 to 5 years old.
Yep, and
He's
huge.
massive.
Yeah.
Now, is this full-grown Henri, or is Henri? I mean, that's a lot of growth in a couple years. Tell me, I mean, is this as big as Henri's going to get, or should we expect a lot more from him in the years to come?
So Henri is probably about like 25 now, and if interesting enough, you look at his back, you can see they have these different parts of their shell called scutes, and this whiter ring around the outside is where it's growing. And the thickness of it is showing that he's growing at a good rate. So potentially Henri could get up to 100 pounds, 100 plus pounds. So because he's a male, he's going to grow a little bit bigger than a female would stay under 100. And males can get up to like 120, maybe even a little bit bigger.
So now as Henri grows, obviously he's going to become much larger. Does Calm have any other tortoises that will be his size, or is he going to be kind of a really unique animal out there for his size? And I mean, obviously being unique, not from California, but also the size as well. I don't think a lot of people see a tortoise that's 100 pounds, 120 pounds.
So right now, he's pretty close to the size of one of our biggest desert tortoises, but he's going to be way bigger than those tortoises.
So the current enclosure he's in, not his final habitat out at Calm, he's going to need a lot more room.
That is
for
correct.
him? Okay.
Where he's going to end up out at Calm is going to be closer to the farm. He's going to get a whole new exhibit out there where he'll be able to grow into it and reach his full potential size.
Oh man!
And he'll have a nice big house out there too.
Okay, so that's what I was. Okay, also, I know a lot of the animals out at Calm right now. Some of them are going into hibernation with holiday lights. A lot of things, very cold sometimes. And California's not always the coldest place, especially Bakersfield. So, does he have any other different needs or a different daily activities compared to the natural California tortoises, the desert tortoises that are there? Is there anything different about him because he's not from the area?
Yep, so that's an interesting thing that you brought up, because if you went out to Calm right now, what you would see is all of our desert tortoises aren't on their exhibit. They're off in another location doing what's called brumating, where their bodies kind of slow down for the winter. It's not a full deep sleep like people think of as hibernation, but it is fairly similar, and their heart slows down to a real slow rate. Their metabolism slows down, and Henri doesn't do that because he's from a different area.
Okay, so because of that, what are the different things you have to do as a daykeeper for him that typically you wouldn't do this time of year, but now you're having to kind of switch up how you operate because of what he needs to thrive and be successful in this environment?
So one important thing that me and my team have done is get Henri a heated burrow. So because he's staying outside full time, he still needs heat even though he's staying outside to be able to maintain his bodily functions. He's not going to sleep, so he is eating when it's warm enough, and he is going to the bathroom. And because they're reptiles, they use the natural heat of the environment is what they use to power their metabolism.
Fantastic. Now, if for those going out to see holiday lights out at Calm right now, running every night, except for Christmas through towards the New Year, would they potentially see Henri in his habitat, maybe in that burrow, in the heat lamp area, or is he pretty much tucked away for the night when he's there?
So his doghouse that he goes in with all of his heat for the night is a dog flap on it, and usually they won't have, they'll just stay in the burrow overnight. But they can do fine into temperatures up to 45, and we've actually come in and found that he's gone after his food plate overnight.
Oh, okay.
So
he's kind of like, hey,
there's
what's going on
definitely
there?
some things.
Well, it
that
looks like he's
doing
enjoying
overnight.
the cable also. He's a little something a little extra for his
So
day.
Henry's known for getting into whatever he can put in
He's
his
definitely
mouth.
showing it out right now. A lot of people I know, they like to, tortoises are slow. This guy's moving and grooving. I mean, I know not everyone saw it during the intro here, but this guy is all over the place. Now, speaking of holiday lights at Calm, I know that right now it's a big time for you guys. For people who want to go out, Meg, tell us, how does it benefit Calm? What can people expect to see out there if they go out and check out the holiday lights?
Thank you. So all the proceeds go directly back into Calm. We have a master plan that we released last year. So those funds go into supporting that master plan as well as supporting the animals out at Calm. So all of our tickets are on sale online and in person at calmzoo.org. So you can buy your tickets there or come in person and buy those guys.
Fantastic. I mean, seeing Henri out here, seeing the great work, and especially the fact that people think, oh, I have to go to LA or San Diego or Fresno to see something unique or different. We have a whole host of California native animals, but to also see an animal such as Henri that is not native here, but is a unique family member out at Calm for people to experience and to know that he's going to be 5 times as large here soon. I'm very excited to see how much bigger Henri's going to get. And the next time we have him out in studio, I'm sure, maybe we have to get a larger vehicle to transport Henri to get him
He's
out
pretty
here.
big. I had a workout there a minute ago getting him back. So.
Absolutely. Well, thank you guys so much for coming out. We really appreciate Calm being a part of this program and allowing our viewers to really get a taste of what's out there and to see different parts of the county. So thank you guys so much. We'll be back with more right after this.
So when we're working with arithmetic sequences, which is something when we start with a number and then we continue to add by a specific number each time. So in this case, we're starting with 3, and of course we're adding by 2 each time. That's pretty obvious right there, we can see that. So arithmetic is either adding or subtracting by the same number each time. So what we want to be able to do is we want to be able to determine what would be the 12th number in this sequence or the 525th number in this sequence. And of course we don't want to keep writing everything out. We want to be able to figure out the formula. So this is what we're going to do. So we go ahead and we call our term numbers, we kind of do some notation that looks like this. This is term number 1, term number 2. We have these little sub numbers, term number 5, and this one of course is kind of like our mystery. That's the one maybe we're looking for. So we're going to write an equation that shows us how we can get to that. So if we look at term number 1 of course is 3. Term number 2 we've decided of course is 5, which of course is just 3 plus 2. Term number 3 is 7, which is my starting number of 3. We're always starting with 3 plus 2 more. And of course here we can start to see that we develop this pattern because we're adding 2 each time. So we always start with 3 and then we continue to add. Now continuous adding is also multiplication. So if I look at this, of course this is 3 plus 2 times 1. This is 3 plus 2 times 2. This is 3 plus 2 times 3, because of course we have 3 2's. And this is 3 plus 2 times 4. And we're going to continue this pattern. So when we look at this, again, we're going to notice that my term number here, if I wanted to look at this one is actually 3 plus 2 times 0, right? Because of course that's 0, just leaving us with the 3. Here my term number 2, I've only multiplied by 2 1 time. My third one, I've multiplied by 2 2 times. My fourth one, I've multiplied by 3 times. My 5, I've multiplied 4 times. So when I get down to here, I ask myself, well, I always start with 3. How many times have I added the 2? Well, if this is a sub, say, 50, how many times did I add 2? I didn't add it 50 times, I actually added it 1 less. So my number here, represented by the n, I'm going to subtract 1 off of it. That's how many times I've added the 2. And of course, I add that to my starting number of 3, and that's how I can get my equation for whatever term I am looking for. And that's just one more way we can see patterns in mathematics.
All right, back in studio with us, we've got Roxanna, a 5th grade student from Berkshire, and from his little visit with Henri downstairs, we've got Mickey back in
It wasn't a little visit, man. Henry's moving and grooving.
I know. I was surprised at how
dude was
fast he was
everywhere.
moving.
He was ready to take off and drive and go check out
He'd be
downtown.
off property by now if he kept going.
He was having a good time, man. And just to know that he's going to get 4 or 5 times as large.
That's when we'll let you lift him up and move
Oh, is
him
that
around.
what? Yeah, I can't wait to throw my back out on TV. It'll be great. It'll be a fun time.
All right, so Roxanna has been working with coordinate planes so far today. Had never done anything with them before, right? So
Yeah,
you
she
learned a
should have
little
because
bit.
it's a 6th grade standard, so
Plus,
credit
she's
to
in
you.
5th, so she'll be getting ready
That's
for
right.
set.
We're here to prep. You're going to be dialed in for next year. So.
All right, so why don't you guys head on over to the board and do a little bit of work with that right now for a couple of minutes.
All right, so...
And she already is familiar with the names of the quadrants.
Okay, so let's review. We have quadrant.
1,
Okay, there I was all right. And then we have number
2,
2, and then we have
3,
3.
4.
Perfect. Now, I'm going over this with my 6th grade students in class right now, and we're just literally 2 or 3 days ago talking about the quadrant names, their numbers, and a lot of students are like, why is it in Roman numerals? I said, well, it's just what we do. But I'm going to defer to Mike if he has an answer on that as to why it's Roman numerals or not. Think on that for a minute. If you know why, help me out. If you don't, that's all right.
Very good.
We're going to go with the teacher
Keep working.
told me so answer. So now in quadrant 1, what do you notice? This whole area, all of these numbers have what in common, you think?
They're all positive.
They're all positive, very good. So a lot of students will think, okay, these are X, comma, Y setups. So if a student sees it, it's just positive, positive. Their mind can automatically think quadrant 1. Now, if I look over here in quadrant 2, what's different about these X values?
Those are negative.
There's a negative. Excellent job there. Now, what about the Y value, though? Because the Y's are still up here.
Those are positive.
Excellent. So are you noticing any patterns here?
So there's like different.
That's all right. So on one side, the X is positive, and on one side, the X is...
Negative.
So we call that a reflection. You know, you look in the mirror, things look the same, but it's opposite sides. Like if you go to scratch like the right side of your head, it looks like the left side in the mirror, things like that. Yeah, so we call that a reflection across the y-axis because it's crossing the y-axis. It's almost like looking at that mirror and, okay, well, the y is still on the positive side, but the X reflects from the positive to the negative, all right? Now let's jump down here to quadrant 3. Quadrant 3, what are our X values?
Those are negative.
So we have a negative X. What about our Y values down here?
Those are negative too.
Very nice. So now again, we see another reflection across this time the X-axis. Well, the X's are still negative here, but instead of being positive Y's, now we have...
Negative Y's.
There we go. So now if we go to quadrant 4, I want you to fill it in. What's our setup in quadrant 4? What's our X value? Are they positive or negative? And then our Y values, positive or negative?
The X value is positive.
Okay.
And then the Y value is negative.
Yeah, great job. Yeah, because we're going down. A lot of students, sometimes they understand more easily the x-axis. You know, think of like a number line. You know, a lot of years in school, we've always seen number lines. But students, in 6th grade, usually the first time they understand that there's a whole nother side of the number line of the negatives, and that's usually something they can deal with because we see horizontal number lines. When we go to the vertical, students go, whoa, 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 Mr. Kushine, I don't know what you're talking about, man. I go, don't panic. So here's one recommendation I'll give to you. I like to think of it like the beach. Now, here's our water, and when we go up, we have a positive elevation, and when we go underground, how would we represent that?
It is a negative.
It's a negative. But here in Bakersfield, we're approximately 380 feet above sea level. So if we were to take the floor out from beneath us and stare down, we would have to go 380 feet until we touch the ocean. Pretty weird to think about it, right? And that's because we have to go over hills, and Bakersfield sits this high above the ocean, approximately about 380 feet. But we have places like Death Valley, which are below sea level. And a lot of people think, well, it's under the ocean. Well, it's not that it's under the ocean, but at Death Valley, they might have the city or the area down here, where if they were to walk straight towards the ocean, if they were to come out in the ocean, they would be 200 to 300 feet below the water. So there are places in the United States and around the world where you are above where the water would be, and a lot of places where you would be below where the ocean level would be. So a lot of students don't understand that quite as much as we get into positive and negatives, but hopefully that gives you a little taste of what's coming up in 6th grade.
There you go, nicely done. And Mick, I'm surprised how similar we think, because we went over the same things while you guys were downstairs with that, but hopefully Roxanna's got a solid understanding on that right now.
That's right.
And the reason they are Roman numerals is because the other numbers that we're using to plot the points, the Arabic numerals,
Okay.
don't get confused, because otherwise you might see the 1 and think, all right, what's
That's
the
kind of
one
what I
up
was
there
thinking,
for?
but I was like, maybe it's not that simple.
And that's
maybe
why
it's
Roman
not a factor of
numerals were
confusion.
opted for.
Well, there we go. Boom. So if your teacher asks, why are there Roman numerals? You're like, ha, I got this, easy peasy.
So for some great problems so far, and for learning a little bit about the coordinate plane, you've got yourself a meal courtesy of our friends at Chick-fil-A. So congratulations. Hopefully you have an opportunity to head on out there and see Troy. So if you go to Chick-fil-A, you have to go in and you have to ask for Troy. And if you're wearing the Do the Math shirt, he's just going to love it, because they love Do the Math over at Chick-fil-A. All right? So congratulations on that. We'll be back with more right after this.
What are the Trojan asteroids? Well, let's begin by going back over 4 billion years, when the newly formed solar system consisted of trillions of tiny little rocky and icy objects. Many of these objects came together to form the planets. The majority of the others were scattered into the distant reaches of our solar system and beyond, but not all of them. Some of them are pristine asteroids that now orbit with Jupiter in 2 huge swarms leading and trailing the planet. They're known as the Trojan asteroids. They're really, really mysterious, and we think that they come from the outer solar system. They're also really special in terms of understanding the evolution of the solar system and understanding the evolution of the planets, because they have remained gravitationally stable for over billions of years. And astronomers have only been able to study these distant and enigmatic small bodies from Earth. But all of that is about to change. NASA's Lucy mission will embark on a 12-year journey to visit these primitive asteroids. And it's going to be really exciting, because it'll be the first time that we are able to see these objects up close. So what are the Trojan asteroids? They're asteroids that orbit with Jupiter around the sun that ultimately hold the clues to the formation of our solar system.
Is NASA aware of any Earth-threatening asteroids? No, there is no asteroid that we know of that is concerning in terms of impact hazard. Now, we know that asteroid impacts have happened in the past and can certainly happen in the future, but we should keep in mind that those are rare events. An asteroid impact that could cause serious regional damage only happens every few thousand years or longer. Still, it's a good idea to protect us against that possibility, and the rule of the game is find asteroids before they find us. And that's why, for over 20 years, NASA has been funding search programs to observe the sky pretty much every single night to find and track asteroids. And we've been doing a pretty good job at that. So far, we've discovered more than 1 million asteroids, including 95% of the asteroids that are greater than 1 kilometer and that could come close to the Earth. Once we discover an asteroid, we project its motion into the future to assess the possibility of an impact with Earth. We have a scale called Torino scale that helps us rank the risk coming from each asteroid. It goes from 0, which is lowest risk, to 10, which is highest risk. And the good news is that for all the asteroids that we've discovered so far, the Torino scale is 0, so lowest risk for the next 100 years. So, is NASA aware of any Earth-threatening asteroids? No, but we will keep searching the skies just in case.
2/16.
All right, well, Mickey and Roxanne are already busy
Okay, so
on one of the
6 up
division
here.
problems that Roxanne is working on in class right now. So, Roxanne and Mickey, take it away. Let us know where you guys are at.
All right, so Roxanne, we've already talked about how 36 couldn't go into 5, and then you told me it can go into 57 one time. We subtracted that and we got
218.
218, and you figured out it could go in
6 times.
6 times. We did the subtraction. We're left with 26. Now, talk to me now. Can 36 go into 26?
No,
Okay, so what do we have to put on top to show that it does not go in?
a 0.
Go for it. And a lot of students will always think, well, it doesn't go in, just move on. And we still have to admit it doesn't go in by putting in that 0. Now that we've put in the 0, what are we allowed to bring down to continue helping us?
A 4.
Okay, let's bring down the 4. And that gives us 264. Now, we've done a lot of math up here. Have we already figured out how close we can get to 264?
Yeah.
What do you think?
Wait, maybe we should use the 7?
Yeah, I think that's a great choice. It's only 12 away, and we're dealing with 36, so I think that's going to be perfect. So what number do you want to put up top?
The 7.
Okay, and then we'll subtract.
252.
Okay, go ahead and subtract that. Tell me what you get.
4, 2, that's 1, and then that's 0.
Nice job. So I want to pause here for a moment because in 6th grade, there's a really big focus on the understanding that a division problem can have 2 types of answers. We can have a remainder to turn something into a mixed number eventually, or we can also make it a decimal. So we're going to work with both answers right now. Okay? So have we already used all the numbers up top?
Yeah,
We have. Very good. Do we have anything left over?
we have the 12.
We have a 12 left over. So if we had to write this answer down, I would put 1,607 remainder how much?
Of 12.
Remainder 12. Some students put a lowercase r, some do a capital, but we have a remainder 12 here. But there is, like we talked about, there's a remainder answer as a quotient, and there's also a decimal. Have you talked about how to get the decimal answer?
No.
That's okay. All right. That's why we're here on Do the Math. That's what we do. So what we'll do is we'll put a decimal here to admit there's no more values that are whole numbers. We're going to have to venture into smaller numbers. Now, at the end of this, what number or digit do you think I could put there to represent this place value?
Like this place value?
Yeah, there's a missing one here. If I don't have anything there, what do you think we could fill it in with? It rhymes with a hero.
Oh, here. 0.
Yeah, it's 0 the hero. He always helps us out when we have those place values that we don't really have anything in, but we can always put one in there. So now, 36 into 120. And I'll give you a hint. It's less than 4. So what do you think we want to do? 36 times, if it's less than 4.
3?
Let's try 3. 18, 108. There we go, that works. If we were to subtract 108, a funny thing is going to happen. We're going to get 12 again. That's really different, huh? So we put the 3 up top from our multiplication. Oh, Lord, I didn't mean to do that. Hold on there, give me a second. Figuring it out. There it is. All right. So you said 3, correct?
Yeah.
Let's put a 3 up top and the decimal after in the tens place. Perfect. Now, I told us that we are going to continue to get 12 again and again and again. So this is a special type of quotient we call a repeating decimal. Because every time we're going to continue to get a 3 up here, and we could do it all for a billion more years. We're going to continue to get 3, 3, 3, 3, 3. So, but this is how I want to talk to you again, showing you in 6th grade, we really focus on there are 2 ways to get a division answer. We can have a remainder, or we can also have a
Decimal.
a decimal. Very good. In this case, it's a repeating decimal. Sound good?
Yeah.
All right.
There you go. First one done. All right. 636-4357 is that phone number. We do have phone tutors available until 5:30 this afternoon. Call in. We give you a Holiday Lights at Com ticket, complimentary of KCSOS and our friends at Com. Right now, we're going to go to the phones. Benson, how are you today?
I'm good.
And you are in 5th grade, correct?
Yes.
All right. Well, Mickey, when you guys, you've already got the board cleared.
All right. We're always ready to go. All right, Benson.
Benson, as soon as you're ready, let's hear the math problem that you're working on, and Mickey and Roxanna will write up some information for you.
So, a work crew of 3 people requires 3 weeks and 2 days to do a certain job? How long would it take a work crew of 4 people to do the same job if each person of both crews works at the same rate as each of the others, and each week contains 6 work days?
All right, so we're going to go through it again one more time because there's a lot of information in there. So read the first sentence again.
A work crew of 3 people requires 3 weeks and 2 days to do a certain job.
All right, next part, the 4-person work crew.
How long would it take a work crew of 4 people to do the same job if each person of both work crews works at the same rate as each of the others?
And how many work days are there in a week?
You said 6 days, right, Benson?
6 work days.
All right. So, Benson, in class, what have you guys already talked about that might give you an idea of how to solve this problem?
So, in class, we've been learning how to, well, something that would probably help me with this is, at first I was thinking about like long division.
Okay.
But I noticed that there was an easier way to do this, and we can just do simple multiplying.
Okay.
And dividing.
All right, so, and I'm going to give you kind of a twist of how I'm thinking about approaching this problem. So you said 6 days in a week, correct?
Yes.
Okay, so I want to break these weeks up into days, so I'm not dealing with weeks and days, okay? So I'm thinking 3 weeks is going to become how many days, Benson?
3 weeks would be 18 days.
Very nice. And then if we add on the other 2 days that they have, how many days in total is that?
20 days.
Okay, so the 3-person work crew is really taking 20 days to do the job, correct?
Yes.
Okay, so now I'm going to set up in 6th grade what we call a ratio, and that's basically showing the relationship that 3 people can do the job in 20 days. All right? So again,
Okay.
a ratio is going to allow me to show the relationship of 3 people, not PowerPoint, 3 people, and it's going to take them 20 days. Now over here with this 4-person work crew, the question is how many days will it take them, correct?
Yes.
Okay, so we need to figure out a way to show how much each person is working per day. So what are we thinking?
Yeah.
Let's see, 20 days, 3
So-
people. Talk to me, Benson, what are you saying?
Since each person is working since each person is working for 20 days, we multiply it by 3 and we get 60 days.
There you go. So
Okay.
do that.
Okay, so it's 20 days per person, not 20 days
So go ahead and
total?
do the 3 people terms that go, so you're going to get 60 and then divide it by the 4 people.
I get it. Okay, I get it. Okay, I'm sorry. There's a couple different ways I'm thinking of how we could approach this one here. Okay, so
Right, 'cause
Benson,
there's
you're
a
saying
couple ways to
60
do it.
days in total, yes? That's
Right.
what we're saying here? Okay.
And the first thing I wanted Benson to do is figure out, is it going to be more or less than the number of days for 3 people?
All right, so we're saying 60 days in total. And then, Benson, I know you talked about multiplying and dividing. So what Mike is talking about is now 60 days divided in total. You know, this is the total project time. But instead of having 3 people to work, now we have how many in our new work crew, Benson?
We're going to have each person work at 15 days.
Right, because there are 4 people. Very good. Yep. So when we do our division, we now notice it's going to take 15 days to do the same job. Nice job, Benson.
Yeah, Ben, for calling in today, Benson, you've got yourself a ticket to Holiday Lights at Com. So congratulations on that. Hopefully you have an opportunity to head on out sometime between now and January 4th, except for December 25th. Great work right there, Benson, and nice work also, Mick. It took a little bit of,
Yeah,
because there's different ways to do
thinking
that
ratios,
problem.
but then I also thought, well, 3 people turning into 4, you're going to eliminate a third of the work, or work a third. I don't know. There's a couple different ways you can kind of think about the division in percents of that.
But with the help of Benson, we got through it right there.
Benson's the man. We're making it happen. That's how we do
We'll
it.
be back with more right after this.
Each passing day, we spend more time on computers and expect them to meet more complex needs. Computer hardware engineers have a leading role in the research on and development of advanced computer technology and even influence how it's used. Computer hardware engineers research, design, and test computer systems and components such as processors, circuit boards, memory, and storage media. In most cases, the goal of computer hardware engineers is to discover ways to make computers faster and more powerful. Some more specialized engineers design other devices that incorporate computers like cars and medical equipment. Some work closely with software developers to design phones, tablets, and other devices. Computer hardware engineers need to be creative problem solvers and work well as a member of a team, using their powers of reason to find original solutions. Usually, computer hardware engineers have a bachelor's degree in computer engineering, though degrees in electrical engineering or computer science are also accepted. Some positions require a master's degree. Many employers expect computer hardware engineers to have at least some familiarity with software. In this fast-moving millennium, few shape our information world like computer hardware engineers.
Developing the tools and technologies of tomorrow requires hard work today. Computer and information research scientists invent new approaches to computing technology and improve the use of existing technology. They study complex computing problems and are often at the forefront of solving them for business, science, medicine, and other fields. These research scientists build algorithms or sets of instructions that tell a computer what to do. They may use an algorithm to develop a new computing language, create programs to control robots, and simplify the ways people interact with computers. Their work often leads to technological advancements such as better networking technology, faster computing speeds, and improved information security. In general, computer and information research scientists work at a more theoretical level than other computer professionals. Computer and information research scientists work for the federal government, computer systems design firms, research and development departments, and for colleges and universities. Most positions are full-time. Most computer and information research scientists need a master's degree in computer science or a related field, such as computer engineering. For federal government jobs, a bachelor's degree may be sufficient.
And just a programming note, today, December 11th, is the final live broadcast for Do the Math for this first semester of this season, and we will be back January of 2025. In studio, we have Roxanna, a 5th grade student from Berkshire Elementary. Learned quite a bit about the coordinate plane already today.
You can never learn too much about the coordinate
great
plane.
work with division,
all the good stuff.
And now, with one of the pages you brought in, you selected number 12 randomly, so that is problem number 12 from your page.
All right, so talk me through. We've already done a division problem together. Your turn to take the lead. Tell me what you want to do, and I might ask you some questions to help me understand what you're doing.
So first, we cannot divide 45 with 9. So we have to go over to here and do 95.
Okay.
45 and 95. So first, we will put a 0 right there.
I love it.
And so we could do 45 times 2.
Okay, we'll see what that gets us. You didn't want to do times 1, too small?
I think.
All right, good idea.
5 times 2, that would be 10. 2 times 4 is 8, and that would
Yeah, pretty close, huh?
be 9.
All right, we'll go 2 times. I like it.
And so now we subtract.
What about the 2 on top? You want to keep it?
Oh.
Okay, all right, just checking. Before we forget about it, we keep going down there. Okay,
Yeah.
keep going.
So 5, that's 5. And then
Okay.
that's just 0. And now we bring down. That would be 50. So now we would have to do 45 times 1. That would equal 45.
Okay.
And we subtract.
All right.
Won't subtract that.
All right. I like that you didn't do that. A lot of my students will say 0 times 5 is 5. And I'm like, if you have 0 fingers, you can't take 5 fingers away. All right, go ahead. Keep going. 10 minus 5.
That will be 5.
Okay.
And that will be 0. And then we bring down this number. That will be 50 again. And I think you should do 45 times 1 again.
Are you noticing anything kind of with like the problem we just did with that repeating decimal? Are you seeing anything similar here?
It keeps equaling 5, and then you add 0 back down.
Yeah, so what do you think is going to happen with this answer? Before we finish this, what do you think is going to continue to happen?
It'll probably equal 5 again.
All right, yeah, I'm thinking the same thing. So now in class, when you come across a problem like this, does your teacher want you to put a remainder or make it into a decimal?
I think she wants us to make it to a remainder.
Okay, all right, go ahead and finish it up then.
4, and then 10, and then 10 minus 5 is 5, and then that's 0. And we don't have anything else to bring down, so the answer is 211 with a remainder of 5.
All right, now there's a way to check this. Do you know how to check your answer?
I think I did, but I forgot.
That's all right, that's all right. So that's why we're here. All right, so we have currently a division problem where 9,500 divided by 45 gives us a quotient of 211 remainder 5, okay? Now, if you turn this into a mixed number, you would have 211 with 5, that's our remainder, out of 45. Okay, now I'm going to show you 2 ways how this can help you. It's something, I'm trying to get ready for 6th grade a little bit while we're here. So I'm going to show you how you could use it over here and how it transitions into 6th grade. Okay, so what we can do is we're going to take this whole number from the quotient and multiply by the number outside. So I want you to multiply 211 times 45 over on the side there.
Okay.
And if you need room, we can erase it.
Okay, yeah.
Yeah, just go and use the side of your hand. Perfect. Perfect. All right, 211 times 45.
211 and then 45. Okay, so I'm going to start off with the 5, and I'm going to multiply it times 1, and that would be 5.
Okay.
And 5 times 1 again would be 5, and 5 times 2 is 10. So, and then we would put a 0 right here, and then we would use the 4.
Okay.
4 times 1 is 4. And 4 times 1 again is 4.
Okay.
And 4 times 2 is 8.
Well done.
Okay. So now we would add.
All right.
Yeah. 5 plus 0 is 5. 5, 6, 7, 8, 9. That'd be 9. And then 4. And that'd be 9.
All right. Now we're pretty close to this 9,500, but what piece are we missing?
I think.
Did we have something left over at the bottom?
Oh, 5.
We had the remainder 5. So now you get to take the product and add that remainder 5 in.
Okay.
And if we do that, what will that get us to?
I think that would get us to 9,500.
Yeah, you're absolutely right. So that's where it's crucial to always have that accurate remainder, because when we multiply, the remainder is the final piece we add in, and if it matches, we've done our problem correctly. Now in 6th grade, we use the same concept, but we turn it into a mixed number, but we don't like to multiply or divide with mixed numbers in 6th grade, so we have the opportunity to change it into an improper fraction. And to do that, we multiply 45 times 211. Isn't that what you just did?
Yeah.
It was. And then what did you do with the 5 at the very end?
Then we added it.
And we do the same thing in 6th grade. So at the end of that, if I turn this into an improper fraction to use with multiplying or dividing or adding in 6th grade, that would become 9,500 over 45. Now another thing you learn in 6th grade is every fraction has a secret identity. Did you know that? It has a secret identity. My students think it's super silly, but it really does. Every fraction is a division problem in hiding. All of these are related somehow, because this fraction is really 9,500 divided by 45. And if I get that, I get 211 remainder 5. And I could take these numbers and turn them into this mixed number. But we just changed it into, so you're seeing how they're all related, and that's something that's really crucial in 6th grade. If you can understand that all 3 of these pieces has something to do with each other, it's going to make a lot of 6th grade really easy for you, because you're going to begin to see patterns in how things relate to one another.
Yeah.
What do you think? It's kind of nerdy, but is it kind of cool? It's kind of cool, huh? That's what I'm talking about. Mike, how do we do?
There you go. Well, I'm glad that you guys were able to see the connections between all of those and talk about the transition from 5th to 6th grade and how those are going to be related right there. All right, we'll have your final problem coming up right after this.
Welcome to Cal Maritime, the most unique campus in the California State University system. There are several reasons why I chose California State University Maritime Academy, but I'll start with one. Located on a scenic waterfront campus in Vallejo, Cal Maritime is one of only 7 degree-granting maritime academies in the United States, and the only one on the West Coast. About 71% of the Earth's surface is comprised of water, making the maritime transportation industry the backbone of international trade and the global economy. By training the next generation of mariners, engineers, scientists, policymakers, business professionals, military service members, and global leaders, Cal Maritime is positioning the state of California for economic vitality in America's Pacific century. We have the highest employment rate in the CSU system. Simply put, we are answering a greater call to help build our nation's future by land and by sea. Here, intellectual learning, applied technology, leadership development, and global awareness are our 4 compass points that symbolize the key elements of Cal Maritime's commitment to educating and preparing cadets for the future. These values, paired with the dedicated work of our faculty and staff, prepare cadets for the world, and prepare the world for cadets like us.
My name is Kalai Pratt. I'm born and raised in San Francisco. I'm currently an International Business and Logistics major, or IBL for short. I chose Cal Maritime because I wanted a place that would set me above and allow me to practice my leadership opportunities. At Cal Maritime, we're challenged to think critically and independently. Our smaller class sizes ensure we get the individual attention we need with our faculty. As the demand for maritime industry professionals grow, Cal Maritime continues to consistently produce skilled leaders who are ready to step into leadership positions upon graduation in order to answer the call and solve for an ever-changing and sometimes uncertain future.
My name is Kai Kraus. I'm from Oxnard, California, and I'm studying Facilities Engineering Technology. One of my favorite things about Cal Maritime is the learning I get to do outside of a traditional classroom. Learning isn't just happening in the classroom, but out on ships and vessels. So we get the real hands-on experience with the latest technology that is being used in our respective fields. It is instilled in cadets early on that you'll be a lifelong learner and problem solver. You can use your knowledge and skills to solve not only the current challenges, but the challenges that are yet to present themselves.
My name is Ryan Okada, and I'm from Oakland, California. I'm studying marine transportation and hoping to sail on an American vessel. I currently serve as the president of ASCMA, which is the Associated Students of Cal Maritime. If you haven't noticed, we wear uniforms. It's part of our campus culture as the Corps of Cadets, which encompasses our student body. Our uniforms are a physical representation of our commitment to each other as cadets and help foster a sense of belonging and equity. But it's not just about uniforms. Since 1929, Cal Maritime has been developing leaders. Participation in the Corps of Cadets, athletics programs, and the Edwards Leadership Program helps to develop self-discipline, self-esteem, and character, which is critical for success and is a vital part of our campus culture.
My name is Anjali Sharma. I'm from Fullerton, California. I'm studying International Business and Logistics, and I'm preparing for a career in the United States Marine Corps, hopefully going to commission as a second lieutenant. I know Cal Maritime has offered me opportunities to be a global citizen. In my time here, I've studied in Morocco, Japan, and India. All cadets are required to travel abroad in order to graduate. It's one important way Cal Maritime makes sure cadets leave with a global perspective. We gain valuable experiences either on summer cruise aboard the training ship Golden Bear or on non-school study tours around the world. Cal Maritime sponsored 3-week study tours to international locations such as Costa Rica, Vietnam, France, Morocco, and Northern Europe. Provide our cadets with a valuable exposure to the business environments and political issues around the globe. Whether you're working shoreside or at sea, you have to have a working knowledge of international politics and economics, environmental and cultural awareness, and global dynamics.
We are California State University Maritime Academy, defined by this system of beliefs that makes us unique as an institution of higher education. Because, as our motto states, to work, to fight, we are ready.
Another one of the great places to go while in California. A little frog in my throat right there for a second.
Yeah,
Give me a
that
little
porpoise,
something like
man.
Henri
You live
that
with that
tortoise
porpoise.
downstairs right there, munching away and getting that going right there, moving around a little bit. All right, we have Roxanna in the studio. One more problem for Roxanna to work on, a 5th grader from Berkshire. Mickey, Roxanna, take it away.
Now we get 880 divided by 22. Talk to me.
So you could do 22 times 2. And that would be 4. And then, wait.
Can we get a little bigger?
Oh.
What are you thinking? Okay, 22 times what? What are you thinking?
Oh, I'm at 22 times 4.
Okay, I'll work it out over here.
Yeah.
You tell me. So 4 times 2 gives us?
That would be 8.
And then 4 times 2 again? All right. So where would you write that?
88. And that would be 0. And then we just bring that down, and that would be 0.
We don't have an answer. Where's our answer? He's all alone. So let's walk through it. So 22 could go into 8 how many times?
4 times.
Going to 8?
How
about 88?
8.
All right.
22 could go into 8 4 times.
There we go. So we'll put our 4 up top now. And then you got a 0 down below, but we have to admit how many times could 22 go into 0?
0 times.
So let's put a 0 up top. So there we go. 880 divided by 22. Our quotient or our answer is?
40.
Booyah! That's how we do it. Oh, yeah.
Are you positive it's 40?
We're not negative, it's 40. Coordinate playing jokes. Woo!
Oh, there you go.
You gotta have some porpoise. You gotta have some porpoise.
All right, both of you get over here now. You're going to start doing that kind of stuff.
Hey, what can I say?
Are you
Only the best
positive
here on
it's
doing
40?
the math.
We're not negative it's 40. That's a good one right there. I give you know what? If we had a little symbol for you, I'd give you a little ding.
Ba-doom. I'll do it myself. That's fine. Don't worry
There you go.
about it.
All
I'll
right.
take care of it.
So, what'd you think of that, Roxanna?
It was really fun.
Okay, good. Did you know that you are now an ambassador for Do the Math?
Yeah.
Yeah, you are. Well, you are an ambassador for Do the Math now. Do you know what that means?
No,
Okay, well, good, because most kids are like, yeah, I'm an ambassador, but what does that mean? All that means is you simply have to tell other students and other people about Do the Math. You think you can do that?
Yeah.
Because we gave you your uniform with your T-shirt, right?
Yeah.
So when you wear your T-shirt, people are going to go, hey, what's up with that? What does that Do the Math thing? And then you can tell them all about it.
Yeah.
Do you know how to do Rubik's Cubes?
A little.
A little bit. Well, that's more than I know how to do it, all right? But anyway, we're going to give you a Rubik's Cube, but this is a special edition Do the Math Rubik's Cube. Nobody else has another one of these except for kids that have been on the show. And I think you might be the first student from Berkshire this year to be on the show. So you'd be the only one in whole school to have one of those.
Oh, man.
All right. So that's part of your duties as an ambassador. Coming up, hey, you know what? This weekend over at Mechanics Bank Theater, the Nutcracker will be performing, and we've had the dancers from the Nutcracker on our show talking all about the dance moves and the training that goes into it. All of the students that are involved in the Nutcracker, there are a lot of students from a lot of different schools involved in the Nutcracker every single year, and they start as like, I think they're like 5 years old, a couple of those kids. They start very, very young, all the way through high school, and then when they're out of school, they become professional dancers. The Nutcracker, always fun, always a family great time out. So that is going on this weekend. Also, holiday lights at COM, and if you get to us on social media and send us a photo of yourself doing some math, you will receive a couple of tickets to go to see Holiday Lights at COM. That is going on all the way through January 4th, July 4th, January 4th, and we will be returning on January 7th for live broadcasts. And did you learn a little something today?
Yeah.
Did you have fun?
Yeah.
Excellent. Until we see you again in 2025, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.